dia, obrigado por terem vindo a mais um webinar da Passio. Hoje temos connosco o Michael e vamos falar deste conceito Data Vault 2.0. Porquê aqui o Data Vault 2.0 e porque é que a Passio aqui em conjunto com a Scalefree resolveu organizar este webinar? Por duas grandes ordens de grandeza. Primeiro, nós temos tido nos nossos projetos internacionais, quer aqui na Europa, quer em outras geografias, nomeadamente Estados Unidos, a percepção que alguns dos nossos clientes estão cada vez mais a adotar esta framework, esta metodologia. E há cerca de mais ou menos 2 anos, quando começámos efetivamente a ter um diverso tipo de solicitações, encontramos aqui na Scalefree e na pessoa do Michael, entre outros colegas dele, realmente uma expertise muito grande sobre este tema. Afinal de contas, o Michael é um dos coautores desta versão Data Vault 2.0, que depois vai falar um bocadinho sobre este tema, e também temos trabalhado com eles em alguns projetos cá em Portugal, quer com a componente da formação, quer também com a componente de apoio à implementação. Isto porquê? Porque sendo aqui uma framework relativamente recente, é natural que existam muitas dúvidas sobre as melhores práticas de implementar e tipicamente o nosso apoio, que pode ser muito pontual ou pode ser um bocadinho mais estendido, na aplicação desta framework nestas primeiras waves. Uma outra questão que é bastante importante, inclusivamente também vamos abordar um bocadinho este tema, é o facto de poder existir aqui efetivamente e com base naquilo que é a nossa parceria que temos, por exemplo, com uma ferramenta que é o Airscape para Data Warehouse Automation, onde esta ferramenta tem aqui um papel importante no processo de gestão e implementação de Data Vault 2.0 e inclusivamente está certificada e alinhada com estas melhores práticas.
So let's talk about Data Vault 2.0 and our experience a bit. Yeah, let's get started with what Data Vault is, right? What's behind it? And just to give you a quick background information about our background, my name is Michael Olschimke. I'm the co-author of Dan Lindstedt's book, Building a Scalable Data Warehouse with Data Vault 2.0. That's essentially my masterpiece, where it's 2.5 years of writing. And I learned all my basics essentially, and then applied them later in projects with Scalefree, essentially with Dan together. And I got a Master of Science from in Information Systems from Santa Clara University in Silicon Valley. I have a diploma, German diploma from computer science from Bingen, and I'm an IT guy, right? So and we do essentially Data Vault consulting, we do training, certification, we do assessments of installations, and so on. All right, Scalefree was co-founded by me and by Dan Linstedt together. Essentially, after writing the book, we needed a vehicle to help clients to fully understand what Data Vault 2.0 is, and that's how we founded essentially Scalefree. And our mission is essentially to help clients in projects to apply these concepts to the best of their to the highest value essentially, so they can take full leverage of Data Vault 2.0 patterns essentially. That's the idea. And so it goes beyond training, goes beyond the book itself. Company was founded on 2 books, more or less. The first book was with Dan Linstedt and Bill Inman. Bill Inman is Dan's mentor, essentially. And that was essentially a book on data architecture where Bill and Dan also talk about Data Vault. And that got us, me and Dan, into the publisher, essentially. And that's how we published then Building a Scalable Data Warehouse with Data Vault 2.0. And that's essentially the basis for the foundation for the company, more or less. So, but let's talk about what's more relevant for you, and it's Data Vault 2.0, or should be more relevant for you. So what's Data Vault 2.0? The idea is of Data Vault 2.0, what's the goal here? The idea is that it is a system of business intelligence that provides us all the components to build an enterprise data warehouse, essentially, or to establish an enterprise vision in the end. That's the idea. Well, for you as a business user, you just want reports, right? A dashboard, that's my goal. So who cares how we get to these dashboards and to these reports, for example? Maybe you want something more, not just dashboards and reports. Maybe you want something like you want to feed some information or raw data into external interfaces. We've done some projects for regulators, for example, where we pushed some data to the external regulator so they could use this data for analyzing the bank, for example. You want to have a data platform. Maybe it's not just pushing this data into some reports. Maybe you want to have a data platform where you can run ad hoc queries, for example, right? Where you can quickly build some new solutions based on the existing data. Maybe you can reuse existing business rules, for example, to achieve consistency in your reporting. We use it for data cleansing. Typically, you want to have reports in the end where, I mean, nobody cares, at least on the business side, nobody cares for knowing the revenue per customer duplicate. Well, I assume you have duplicates in your customer database. Everybody has that, right? So nobody cares for revenue per customer duplicate. What you care is having the revenue per actual customer, right? So we need to apply data cleansing in reporting and dashboarding. But if we cleanse the data in the enterprise data warehouse, why can't we just push the cleansed data back into the operational systems, right? That also works. Total quality management goes a bit along the line. Business process automation. Internally at Scalefree, we have a lot of automated business processes. So to be honest with you, hopefully you sign up with essentially for the training. If you do this, at least on our side, there's a web form where you can sign up, but then there will be essentially, you will receive some couple of emails and thank you for registration, right? Some confirmation. But these emails are not, they are essentially fully automated more or less. So they might come from some person, from some email account from a person, but in the end, it's a fully automated process. And internally, we use both our CRM, the operational system, and the enterprise data warehouse for running these processes essentially. But also for data science, running ad hoc queries, building let's say small solutions, prototypes. That's also what we typically achieve with this concept of Data Vault 2.0. So more than just reporting, right? The problem is when we want all this, and there's this in a typical data warehouse project, with or without Data Vault, there's a lot of questions and a lot of challenges, right? So we talk about big data, for example. We have high volume of data of a fast speed of arrival, essentially. We're dealing with unstructured data, multi-structured data these days, JSON files, XML files, PDF documents, video streams, and so on. We want to have a managed self-service data discovery. So it's nice to have access to all the data, but what data is in the box, right? So what data is available to me to build some solutions? Ownership and governance, who owns the data, who's responsible for the local solutions, and so on. Security and privacy. Portugal is in the EU, and there's this GDPR thing, right? So it applies to you as well. How to solve that one? That's actually a big one, a big driver for Data Vault installations these days, because there are existing solutions from the 90s that we apply today. These are proven solutions from a government context, essentially, and they work with GDPR nicely. Auditability, accountability, along the same lines, and managed self-service BI that you can produce your own solutions. So that's a couple of challenges that we see in traditional projects where we have solutions in Data Vault 2.0. And then we also have the challenge of, let's say, traditional organizations where they're not really data-driven, that the access to data is limited to certain users, that a lot of unstructured processing is happening. So you have a challenge, you want to solve, you want to, let's say, introduce a new product, and you want to make some more informed decision than just based on gut feeling, right? So you get some data and then you start processing the data, but there's no clear process of how you process data. There's no defined process, right? So you also end up with some expensive trial and error. Maybe you have to make a decision on gut feeling because you don't have the data, you don't have access to it. Maybe it's not in the right quality. And so you make a gut feeling decision and you will get some feedback from the market, works or not works, right? So that's a trial and error here. If it doesn't work, well, adjust the product, try it again. If you would have the data, if it would be readily available, maybe you could use this data to design your product in the first place. That's what some customers are doing. Right, so that's the idea. And you want to become agile. I mean, you're waiting for new reports, you're waiting for a single attribute to be added to an existing dimension or to an existing report. It takes months and nothing goes forward, right? So how can we become agile from today? Just by having, let's say, agile daily sprints or something, daily meetings? Not quite sure. So Data Vault 2.0 in the end supports agility as well. And the other thing is that what we see in traditional data warehousing is that we have often the case that let's say you're producing, let's say, some solutions, let's say an OLAP cube or a report, and the first solution is quite fast. So you get this out of the door to your end users relatively fast. But then having a second solution attached to the existing data warehouse takes more time. Why? Well, but still acceptable. So let's keep going. When you add the next solution, it takes really long time and a lot of budget. And then you're asking some questions as a business user, right? So how can it be the case that it takes more and more time to produce more and more solutions? Well, tell you the answer. The problem is dependencies. What we have is in traditional data warehousing, but also in Data Vault, we have what we call conform dimensions. Dimensions which are used by multiple solutions. Let's say customer, for example, or product. Those are typically conform dimensions. And the problem is that when you reuse specific assets and you add or modify these assets, let's say sales was good with a certain definition of the customer, and then marketing comes into play and wants just have one more attribute in the customer dimension. Well, this little change affects the existing sales cube, which means that you have to retest the sales cube. And with the third solution, your little change on the customer dimension now affects 2 cubes. So you have to test 2 additional cubes in order to deploy this new functionality, essentially. So the testing effort becomes bigger and bigger over time. And that's a typical challenge we see in traditional data warehousing that we also solved in Data Vault 2.0. In the end, by a lot of virtualization, that's one of the keys here. All right, but that's another challenge. So you want to have some new reports, but it takes more and more time to get them out of the door, essentially, or that you receive them, essentially. So how to solve this? How to deal with these challenges, essentially? All right, so the idea is this. What we're establishing here is is a Maslow pyramid. Maslow, if you know it from university or from school, he had 2 pyramids, right? One was the Maslow pyramid for the pyramids of needs, and then he had a pyramid of data and data processing, which is quite interesting. So what we see is that the most bottom layer here, that's the raw data. That's the data coming from your source system. The first step is in data warehousing is to absorb this data, ingest this data into your data warehouse. Just capture it, don't modify it, just capture it some way. Then we transform, pre-process this raw data into information. That's the next layer. Essentially by applying business rules, transforming the data, cleaning it, and so on, and turning it into the target structure the end user would expect. So the data comes in, the data comes in here on the lowest level in the model of the source system, right? The source system delivers the data, and then what we typically do is we break it up into what we call the individual components of your enterprise data. We talk about that. And for the information layer, the end user will define what is the target structure. I want to have a star schema, maybe a flat and white perspective. I want to have maybe a schema in third normal form, for example, and so on. No matter what, we turn the raw data, apply the business logic, and turn it into the information, the right content and the right structure, what you as a business user would expect. Well, and then the job is done by the IT system, because then you become active. The next layer, the knowledge, is essentially the mental application of the information by the human. So that's out of the IT. I'm done, right? So now it's your turn. So you read the report and, well, you make some decisions based on the report, essentially. And then the next step would be that you internalize the knowledge. You don't need to read the report anymore. You know what's going on anyway. Give an example. Before these global situations, I don't want to name it anymore. So before these global situations that we face at the moment, we used to have the Oktoberfest in Germany, right? You heard about it, I know. So the thing is, let's say you are responsible for, let's say, supplying it. And what you have is 2 products, wheat beer and sausages, right? And well, maybe in the first day of the job, you wonder why in September. By the way, the Oktoberfest is in September. That's when it starts. I'm from Northern Germany, don't ask me why. So so you wonder on the first day of the job, you wonder why in September the demand for wheat beer and sausages in Munich goes high, right? You read a report and you see it was the same in the last years. right? So that's what the report tells you. The line chart says, yeah, in September, October, the demand goes up. Well, you might read additional sources just next to the report. You read maybe some news articles. Hey, there's an Oktoberfest, and it's millions of people coming from all around the world, coming to Munich, joining this Oktoberfest, and that's why the demand goes up. Well, next year, you know that every year, the Oktoberfest is every year with some exceptions, right? So it will be canceled this year, but typically it's every year, and you would see that demand goes up every September, every October. So you don't need to report anymore because you know what's going on, right? So that's a pyramid essentially. So it's essentially a clear process of how we as humans, with the help of IT, process information and internalize this information eventually. All right. So to build such a system, and we use Data Vault 2.0 to build essentially an enterprise data warehouse. And the definition of this enterprise data warehouse is this. First of all, we want to process all data from all the sources of the enterprise, which means that we're looking at your internal data sets, let's say these Oracle databases, MySQL database, whatever you have in your operational setting, could be some cloud applications and so on, right? All data means regardless of structure. So we're looking at the structured data in relational databases, but we're also looking at JSON files, XML files, binary documents, and so on. But also real-time data, batch data, near real-time data. We're looking at internal data, but also external data. Maybe you can purchase some data. Maybe you can crawl some websites and so on, right? That's what we do internally on a regular basis. Watch websites essentially, right? So all this data is being absorbed by the enterprise data warehouse, all the data that's available to you as an enterprise. And then the goal is to feed the data, well, to turn the data into useful information and deliver it to all the users who have an interest in it, who wants to have some information. So even though there might be contradicting business rules involved. So let's say you have a subsidiary, your headquarters is in Portugal, but then you have a subsidiary in, let's say, Germany. And there will be different tax rules to be applied. So it's nice that you want to have, as an enterprise, you want to apply one common set of business rules globally, but that's not going to work. I know it's the best desired, let's say, outcome, but it's unrealistic, right? So the idea is that for any reason, we might need to apply different business rules in certain contexts, subsidiaries, local legislations, or restrictions, and so on, right? And that's the idea. So the goal is to deliver the information to all consumers, regardless of their actual business rules. And it's a distributed solution. So which means that some part of your enterprise data warehouse might be installed on-premise on your local, let's say, Oracle database. Some other parts might be in the Azure cloud, in a SQL Server instance. Some other parts might be in a Hadoop cluster in the Amazon cloud. So that's one reason to distribute the data. Another reason might be technology. Maybe you want to use a relational database to store the structured data and a MongoDB for storing the JSON arrays, the JSON documents, right? Maybe you have the need that, let's say you have give an example. A recent bank that we worked for, they had the headquarters in Germany, in Hamburg, Germany, but they had a subsidiary in Switzerland. And the Swiss financial data about customers is not legally allowed to cross borders, the Swiss border. And so what we've built is essentially a distributed enterprise data warehouse where most of the data was being processed in the headquarters in Hamburg, but some of the data was being processed in Zurich, Switzerland. And we only received some aggregates for benchmarking or for reporting purposes, essentially. That's it, but no detailed records. But if you would get access to both data sets, from a legal perspective, you won't get that, right? But if you would get access to both data sets, you could seamlessly join these data sets. And they also use every bank has a compliance department. That's the next reason now. So they had essentially, they built an enterprise data warehouse for the, let's say, the general user population, right? So all the users had, with some access, had access to the system and could query some information. But then the compliance department came to us and said, well, we also would like to have some data solution, but we can't share the data. So what they came up with is essentially they were working on a separate network. They had their own separate servers, everything was separate. So they set up their own separate database, built a data vault, and they had access to both data sets. They could access their own compliance data set and the general usage enterprise database of the bank. And they could seamlessly integrate that, could take their blacklist and I don't know what data they looked at. They could use their data and join it with the other data from about customers, products, traders, and so on, right? But if you would work in the general user population, you wouldn't even know that there is a compliance data vault because it's on a different separate network, different database. It's completely separated, and you don't have access to it. So you're completely unaware of the existence of this system. That's kind of another distribution, right? Yeah. So technology, organization reasons, legal reasons, and technical reasons. That's typical ways to distribute, but there might be more. All right, and that's how we define the enterprise data warehouse. That's what we want to build. Yeah. So to build this data vault, well, we need more than just a data vault model. Okay. So I don't call myself a data vault modeler because I want to build an enterprise data vault. Having a nice data vault model is nice, but for me, it's more a tool to achieve the enterprise data vault. That's the goal. So Data Vault 2.0 is more than just the model. It consists of all the components that we need to build an enterprise data vault. And yes, the model, let me start down here. The model, the data vault model is part of it. And it consists of hubs, links, satellites, if you know that. The model itself is very flexible, so which means essentially that we can extend more data to it, but we can also react to changes. The problem you're facing is that your source systems change on a constant basis, right? So every sprint, every month, every 2 months, every couple of months, you get some changes on the source system. And your job in the Data Vault team is to absorb these changes. And Data Vault can easily absorb changes to the incoming data, but also on the business rules, for example. It's scalable, it's highly scalable, which means that the Data Vault model itself can span across multiple environments, like on-premise cloud, but also span across multiple MPP nodes, like these, right? Clusters for processing high volumes of data. It can it can process any volume of data at any speed. That's the cool thing about it. And by the way, by design, it's designed this way. And it follows a natural pattern, essentially a hub and spoke design that essentially Dan Linstedt, who invented Data Vault and Data Vault 2.0, he derived the model from patterns in nature. It's an interesting story, longer story. It's maybe good for Q&A how he came up with it. So that's the model. The architecture is a multi-tier architecture. So we got multiple layers. Each layer might be on a different platform. You might mix and match different technologies in the same layer. So it's, again, highly scalable, can span across multiple environments, can process, again, data at any speed, real-time data, near real-time data, batch data, who cares, right? And it supports the integration of NoSQL databases like MongoDB, Hadoop clusters, and so on. Actually, the concept, how we process data in Data Vault 2.0 really is in line with, for example, these schema on read concepts that we see in big data in Apache Hadoop, for example, or Hadoop or all these other Apache products, for example, or projects. So it's very much in line because in the end, that's how you process big data, and Data Vault is a big data concept. It's just based, or it's, let's say, it leverages a lot of technologies you already know. And the methodology is essentially based on consistent, repeatable patterns. So we define a sprint, and that becomes a pattern that gets executed every sprint. Well, in order to optimize, let's say, your productivity, or you want to reduce the number of errors over time, we adjust the pattern over time. That's how we become better, more productive, doing less errors, and so on, based on a pattern, essentially. And then we have the implementation patterns. The implementation patterns are essentially what you see is when you build your first Data Vault, you will realize that all the hubs look very similar, all the links look very similar, all these satellites look very similar, all the entities look very similar. You will see that, for example, the way you load these entities is very similar. The way you use these entities is very similar. So there's a lot of patterns in Data Vault 2.0, and these patterns help us to automate the generation, for example, with Verscape. And and that makes you more productive in the end. So instead of creating, let's say, I'm just making up some numbers here, let's say you're able to produce 5 NADs per sprint. However, how large your team is, I don't know. How long your sprint length is, I don't know. So this number makes no sense, right? But you get 5 NADs done. And with automation, you now get 50 NADs done per sprint. So it increases your productivity, and therefore the implementation patterns, these very technical patterns, they support your agility. And that's why we consider implementation as a sub-pillar of or sub-component of the methodology, essentially. The methodology is essentially based, to a good extent, it's based on, let's say, different concepts, like Scrum, for example. So we have sprints, we have agile sprints, where we essentially deliver functionality into production every 2, 3, 4 weeks, whatever you define your sprint length. It includes different concepts from CMI, from Six Sigma, Total Quality Management. CMI is about process improvement. So you look at your capabilities. It's a capability maturity model integration. You look at your capabilities and you want to improve them, right? So you take your current state, what you're able at the moment, that's your baseline, and based on that, you're going to improve it every sprint, essentially, until you reach an acceptable level, let's say that. Six Sigma comes from mass production. Essentially, the idea is once you have a pattern, producing a report is really like in a factory. You got a request coming in for a new report, you got the blueprint, just go for it and develop it. And at the end of the sprint, at the end of the belt, you got your end product, essentially. Which also means that error, if you face an error in mass production, an error in the outcome is typically due to a deviation from your standard procedures on the belt. You should have moved your hand this way, right, in mass production, but you didn't. You make a mistake. And that's why this mistake in your application of the blueprint turns into a deviation in quality, let's say that, right? And which means that in order to improve quality, you want to make sure that you reduce the deviations in your process. That's the idea. And that's what these concepts are essentially being used. Total quality management, the idea is this: you identify bad data in your report, and total quality management says you should perform a root cause analysis. You should identify where this bad data is coming from. And most probably, it's not coming from the data warehouse. It's coming from the source system, right? That's where the bad data comes initially from. So, and then you should fix the error at the root cause. That's the idea we wrote in the book. Like a first chapter in the data quality chapter, we had a paragraph of like 5 lines where we said how you should do it. But then we also recognized reality. So the rest of the chapter, like 25 pages, is about how you patch bad data in the data warehouse. What kind of tricks you can use to patch the bad data, because that's the harsh reality, right? All right, so we're looking at risk management, governance, versioning of business rules, versioning of business logic. It's all about automation and generation of the DDLs, but also the insert statements. It's all about repeatable, optimized processes. And it's essentially let's say a chocolate box of best practices that Dan, but also we found in projects. What works for us in Data Vault, in data warehousing, that's what we essentially put into this chocolate box, essentially, right? All right. CMI is really about, again, to optimize your current development processes. Give an example. At one client, actually at the same bank, we had a team working, and I mean, the first day, everybody's a bit puzzled, right? New project and so on. But then every sprint, we use the retrospective to look at how we can improve. It was one of the questions. How can we improve the development process? What's our challenge at the moment? And in the first sprint might have been, let's say, the reliability of delivery, right? How can we deliver more frequently? How can we deliver more consistently, right? So we looked at that. The next one we had one question. We had some issues with deployment. So we seriously deployed on a very, very regular basis every month into production, believe it or not. But we had problems. It always, it was a bit, let's say, bumpy, right? Well, for those teams where they don't deploy that much, and I understand people, well, development teams sometimes like to avoid deployment because it's pain, right? And here's the thing. with pain in general terms. You can either try to ignore the pain and get used to it, or you fix the source of the pain, right? So you can either, but to avoid the pain is the problem, because if you avoid the deployment, well, there will be an deployment coming up in maybe 1 year, 2, but there will be an deployment, that's for sure, eventually, right? So, and then you will have very high pain. But if you have a frequent deployment, you have the choice. You either get used to the pain of the deployment, right? Or you fix the problem of the pain. I would go for the second option. I would fix the source of the pain, right? Because I don't like pain. And frequent deployments help in that regard, because most people don't like pain. They want to fix it. And that's another aspect. In the end, to be honest, we realized that we were the source of the problem of the deployment, because the descriptions of the deployment were not quite correct all the time. It wasn't fully understood and so on. So we fully automated the deployment in the end to get rid of humans, to be honest. It was the human factor in the end. Well, we didn't get rid of people. We had enough work for everybody, right? So that's not a problem. So that's the idea here. So you want to really look at your capabilities. What's your current challenges? How can you improve every sprint? And that's part of the methodology, essentially. Also, when do we apply what kind of activities, let's say that? When do we start measuring, for example, or estimating the effort, for example? Makes only sense when you have essentially defined processes available. Without defined processes, you can't really estimate or reliably estimate your effort, essentially. So there's some activities you start early and later. That's the idea of how we use CMMI in Data Vault 2.0 methodology. All right, as I said, in Data Vault, we can use the fact that Data Vault is based on patterns, that all the entities look very similar, that all the sprints are executed in the same fashion, all the artifacts that we produce, all the business value is produced by a pattern in the end, how we produce it, essentially, right? A description of a process. The way we use or create these business values regarding the modeling aspect, like how we derive dimensions, how we derive facts, also follows patterns. Once you understood them, and I'm pitching training here a bit, we talk about that in the training, right? Once you understood these patterns, you can apply them again and again, right? So that helps us to establish these patterns in the first place, and then use automation frameworks like Grascape to essentially generate the outcome based on metadata. And it sounds easy. Well, there's a couple of advantages here, because the thing is this: when you develop your code manually, you again have deviations, because every developer, let's say you have a wiki page that clearly defines how to build hub-link satellites, how to process all your stuff. Well, it's clearly defined. There might be a pattern in SQL in the wiki page, but guess what? The developer goes through it, implements it to the best of his or her knowledge, but you will have errors in it, deviations from how they should apply these patterns, because they're humans. It's all good. So what we see is that all these different artifacts are a little bit different, and that's the deviation quality in the end, because they deviated from how they should do it, essentially based on blueprint, because maybe just because of misunderstandings, right? Or all the errors. So the idea is that once you use an automation framework, I mean, the automation framework just takes the metadata as an input, applies the template that you defined, and comes with the outcome. There's no deviation anymore. That's the idea. So it helps us to standardize the end product. And it really changes the way you work in data warehousing in the end. The architecture, we said, essentially helps us to decouple helps us to decouple essentially the components are decoupled, let's say that. So you might have the architecture itself distributed across different environments. For example, you might have a staging area on premise, and then the enterprise data vault layer where the data vault would reside would be in the cloud, and information delivery might be somewhere else. Doesn't really matter. Everything could be decoupled, essentially. It helps us to reduce the change impact here, to the point that you could build systems with zero change impact, where every modification only leads to new entities, where you only create new tables, create views, but you never alter a table, alter a view. That's an extreme scenario, so I wouldn't recommend it for most clients. but it's possible. It just leads to more entities, and that's why we wouldn't recommend it by default, essentially. It helps us to establish, manage self-service BI. So unlike, let's talk about self-service BI. Self-service BI is the idea, you take some front-end tool or some tool, whatever it is, you directly connect to the data source, process the data, and come up with some report. Fine, good job. Problem is, again, there might be a definition in the wiki that you know and you use it that explains how to deduplicate customer records. Well, good for you, because I've never seen this. So you have it, great, but then you apply it and you also make some deviations on how you should apply the deduplication process. So your end product, your report, will have slight deviations, and therefore the numbers don't match anymore, or they're not 100% correct, right? And what we see in projects is, because you don't have this definition of how to deduplicate your customer records or product and so on, we see a lot of deviations in the end product, in the reports, a lot of deviations. And if you would be the manager here, if you use all these reports, you get one report from one department, another report from another department, customer number, pure, simple number of customers don't match. What do you do? Well, do you trust these reports? Nah, I'm not sure. So the idea now is, with managed self-service BI, the idea is that what would be the counter strategy now? The counter strategy would be to say, well, all the reports that we use in the enterprise will be done by the data warehouse team. There is no custom self-service or something, right? We do everything. Doesn't work either, because the process, even though we are agile and we're speeding up and everything else, well, our development process for a new report takes some time. Let's say 2 weeks, 4 weeks, something, before you see the first draft of the report. And maybe we need 2 or 3 sprints to really produce the final outcome where you're satisfied. Why is that, right? Because you just take the tool, click something together, and you're done in a day. Well, the reason is because we are essentially, we have these defined processes for a reason, because we want to have this uniform standard product in the end, right? We do throughout testing, deployment, documentation, and so on. We have different environments to manage and so on, right? The infrastructure and so on. That's why we need more time. Well, the idea now is that we find a middle ground here. And the idea is that we, as the data warehouse team, realize that we can't produce all the reports that you want. And you're lining up on the door of the project room. I got a door here. You're lining up, and you even though, let's say, you have a requirement for an information requirement in your one hand and budget in the other hand, cash, I couldn't deliver it because I might not have even the manpower, the people to deliver it. I can't find the external consultants because they're not enough out there, right? So I can't deliver it. Even though I have the money, fine, I can't deliver it. Help yourself. And that's the idea. We recognize that we have limited resources, money-wise, human resources, right? We have limited resources. We can't deliver all the functionalities. So the data warehouse team focuses on what we have to deliver, so you can help yourself. And what we have to deliver is the infrastructure, the servers, the tools, but also the integrated raw data. Getting the data from the source, integrating it, and making it available to you. That's actually the easy job for us, because we're automating this, to be honest, right? So that's the easy job for us. But it's hard for the business user because, well, how to do all this is very technical. In the end, it's just a for loop in a Python script, to be honest. But hey, I know how it works, right? That's the difference here. So for us, that's the easy part, the integrated raw data. For us, it's complicated to understand the business logic and apply it to the raw data. But that's where the business shines, where the business says, well, yeah, give me the data and I do it myself because I know the data, I know the business rule to be applied, just let me do it. Why should I explain it to a tech guy, right? It takes too much time. And that's the other side of the coin. So once we provide the integrated raw data, the business can then take the data and implement their own solutions and produce their own reports, essentially. Well, typically what we also see is in managed service BI, that business users like to build a solution, but don't want to maintain it. I mean, running the job every morning when you come to the office, the first thing you have to do is at 8 o'clock, run the script. So it processes more data, feeds it into a report. And when something breaks, you have to fix it. Source system changes. Maybe the business rules change a bit. You have to grant the solution to other users and so on, right? You get busy. So you don't want to do that as a business user. So what you do is you go to the IT department or a data warehouse department and transfer the solution to them. So they should maintain it, right? And that's what they're good at. I mean, that's where they scale, right? So that's great. And what we have is what we call an industrialization process to take over these power user solutions into the more IT-driven part. So it's all in the architecture, in the methodology, essentially embedded. And it's also about integration of hybrid solutions. So data you want to really store the data where it fits. So most of our clients these days have what we call a hybrid architecture, coming up on the next slide, where they integrate a data lake with some more relational engine, let's say a Snowflake database or Hive, maybe Hive managed, for example, but integrate both relation technologies and relational concepts and a data lake, Hadoop, HFS, S3, for example, or MongoDB sometimes. So that's what we call the hybrid architecture. That's the, let's say, the blueprint for data for, let's say, greenfield Data Vault 2.0 project. So when you would start a project right now, I would come up with this slide essentially and say, well, let's talk about this one here. Which means that we actually consider relational staging areas as a anti-pattern these days. Most clients use a data lake, HFS, S3, Azure Blob Storage, whatever, for staging purposes. Or in other terms, we consider your data lake as a big, fat, persistent staging area. That's how we consider your data lake. So avoid the mistake of looking at these projects separately. The data lake integrates with your data warehouse in the end. So there should be, you might have two different projects, but it should be closely integrated and aligned. So the source systems push the data into the data lake. You want to organize the data in the data lake. The thing is, it's always easy to load the data lake. That's the easy part. The challenge is to get the data out again. This error here, that's the challenge. So that's what you want to optimize. And then you have we typically have some relational concept technology available. That's essentially the raw data vault and business vault. And we store this in some relational, either database, Oracle, Snowflake, Teradata, or in some relational concept like Hive managed. It's also, I mean, it's not a relational database, it's some technology, right? So something like that. But you could also have the data vault model on a NoSQL database. And there's some interesting blog article on our blog. Sorry for self-promoting. Interesting article on our blog, how you build a data vault in the MongoDB, which is a completely different database. It's a collection of JSON documents, or a set of collection of JSON documents. So you don't look at relations. And I promise you, data vault will look different, but it's the same concept, right? The same concepts are applied. And then we produce, essentially, once we capture the unmodified raw data in the raw vault, once we apply business rules in the business vault, then we derive our targets, our typical information marks for reporting, dashboarding, maybe for interfaces, for subsequent applications, for business process automation, and so on. Quick comment, when people think about data warehousing, a lot of people have an enterprise model in mind. Like an enterprise model where you define customers and products. There's a relationship between that. Customers buys products, right, or purchase products, and you have descriptions. You have some descriptions for the customers, first names, last names, product descriptions, when did they purchase, and so on. That's their enterprise model. So they describe their enterprise, their business. That's not my thinking. My thinking is, when I hear the word enterprise data warehouse, I'm thinking about rivers, about geography. I'm thinking about a river coming from a source, flowing all the way downstream, down the hill, right? All the way into some target, the sea maybe, hopefully. So that's what I'm thinking of. And then I start thinking about how could I split the river into two to make it more manageable, how to join two rivers or two smaller rivers, right? I don't like the color of the water, so let's make it red or green. I'm not sure if that's good, but let's add some color to it, right? To repaint the color. I might have a basin where I store some water temporarily, maybe some static model. And then I might have pipes uphill where I have some write back into closer to the source, right? And to be honest with you, when you think about your terminology that you use every day in data warehousing, you talk about data sources, you talk about data flows, you talk about joining data sets and data flows, right? So we use the same terms as in geography, actually. And what we do is we design data flows in the end. The goal is to produce a report, and that's your source up there, uphill. So how do you get there? by designing the data flows towards the target. That's how we think about data vault, or at least how, well, yeah, how I essentially influence everybody at Scalefree, let's say that, and also partners like Passio about this thinking, to be honest. So yeah, that's where it is. So the data vault model, to wrap this up, it follows a what we call scale-free architecture, which means that you can extend the data model by more and more data over time, sprint by sprint. It can expand over time. It's based on a natural pattern, hub and spoke designs, essentially, which you will find in a lot of patterns in nature. And it's backed by set logic and MVP math, which means it has been designed for MVP clusters, but it also works on single node systems. But just because of this MVP design, it works well in the cloud. This is a typical model where we have essentially 3 base entities: hubs, links, satellites. Hubs capturing business keys like carrier codes, flight numbers, and airport codes. You have links capturing relationships between business keys. A carrier performed a flight with a flight number from airport A from the origin airport to the destination airport. That's the relationship of a flight, the relationship of business keys. And then you have descriptions, satellites describing either the carrier. So what's behind carrier code LH? Well, it's Lufthansa based in Frankfurt. This is the default color for reporting and so on, right? Then we have these flight numbers. What's behind those? What's behind the airport codes? I'm living in Hanover, so LH is the airport code. What's behind it? What's the address? What's the country, and so on, right? That's all described by satellites over time. But to be honest with you, because I know there's some data vault specialists here in the room, it's a bit more complicated than just 3 patterns. I mean, the base patterns are hubs, links, satellites, but there are some special entity types like multi-active satellites, non-hysterized links. So we're looking at 15 entity types, but all of them are based on those 3. It's just some deviations to deal with certain scenarios in your enterprise data that you have, transactions, real-time data, and so on. But we talk about that in the training session. Yeah, some key findings, really to wrap this up now, is essentially that Data Vault defines KPIs to improve your development process over time. We separate raw data integration in the raw data vault from the application and interpretation of the data. Application of business rules, interpreting the data, that's done in the business vault and in the information mart to be able to support multiple targets at the same time. So we apply business logic once we capture the data. We follow essentially a schema-read approach, but also a extract, load, and transform, ELT approach instead of ETL approach. Yeah, and it's about governance to deal with the implementation patterns, methodology, and so on. The Data Vault essentially has a couple of goals here on the left, and we achieve those goals by having multiple components. It's not just about the model, it's about the model, the methodology, and the architecture, essentially, plus the implementation patterns. All right, sorry for that, I'm done. Thiago, you want to take over? Okay, any questions, guys?
We have, thank you for your presentation. We have here lots of questions. For example, how to start a Data Vault project?
I would say that the first thing is don't try to be perfect in the first place, right? So you want to become perfect over time. That's number 1. So what we typically do is this. We typically start a project by having a series of sprints, and we call the very first sprint a sprint -1. In sprint -1, there will be one experienced guy, and this person will essentially make sure that when the team rolls in, that they can work. So it's all about making sure that the team is operational. We have the right tools. Do we have a meeting room? Everybody has license. I mean, we know the consultants, we know all the team members from at this point. So just create these user accounts. You don't have to give them to me, but just make sure they are ready. So you can distribute the user accounts on the first day when the team rolls in, because why should they wait for 4 weeks or 2 weeks before they get the user accounts, right? And we had these situations at clients. Do you have at least the servers ready? Maybe not the layers installed, which we don't know yet, but the servers should be there, right? So that's sprint -1. In sprint 0, essentially the first people come in, and we have this idea for an architecture. So we want to set up a enterprise data warehouse here at this client, and we have a rough idea because we have a book. We could just take the book and there's an architecture in there, or you just take the slide you just saw. But the problem is, to be honest with you, I don't know if it works for you, because you might use different technologies that I or we haven't used before. We might see it's based on, you might have different people. So it's also based on the skill levels in a team, right? Do you have the right skills for technologies and so on? So I don't know if the architecture we come up with initially will work. And then I want to really fail hard fast, which means that in sprint 0, we set up the architecture, the layers, everything we set up, and then we load some actual data from an actual source through the layers into the target, let's say a dashboard. I don't want to see a full-fledged data model. I just want to establish a data flow from source to target to experience all the issues. And we had lots of issues. We had like issues like the customer, the IT department gave us only a couple of terabytes of storage, but we need like petabytes of data. They couldn't understand why you would copy data every day from the source into the next database. Makes no sense for them, because you got the data already in the operation system, right? So we couldn't create indexes, we couldn't do nothing because we had not enough storage. Stuff like that we want to encounter as fast as possible. Do we have actual access to the source data and so on, right? And if there is something wrong, we fail hard fast. That's the goal, because if you fail in the first 4 weeks, 6 weeks of the project, you still have enough budget to readjust. If you fail with your architecture after 2 years, game over. That's what I want to avoid here, right? So, and then with sprint 1, once we have a architecture that works, sprint 1 is really about delivering business value. So what I'm always do is I'm establishing the focus on business value. Why do we have an enterprise data warehouse in the first place? The business user doesn't care for the fact that you have a Hadoop cluster or something in the Amazon cloud or something. Who cares? They want reports and dashboards. And they also don't care for GDPR, to be honest, right? Or for, they have to care for it, but it's not the primary reason to build an enterprise data warehouse. So once we establish this focus on business value, we deliver business value, an actual report, or at least some progress on the report, sprint by sprint. And with every sprint, we also deliver some non-functional requirements like security and privacy for GDPR, for example, very early in the onset typically, but also like automated deployment, for example, and so on. That's all comes sprint by sprint, essentially. But there is a focus on business value. That's what I would recommend, essentially.
One is how to deal with many tables in the data vault approach, and also another one is very related to this. Is do you agree that in a large enterprise data warehouse, because the number of structures involved in the data vault model, it is almost impossible to manage without automation tool? So
the first thing is the number of tables is not really a concern for the database. So it's typically a concern for the user more. But when you use let's say you want to produce a target, an information mart with certain dimensions and facts. This model, first of all, we recommend using real subject-oriented information marts. Unlike in legacy data warehousing, where we created these big fat data marts, where there were all facts, all dimensions in one big schema, right? No, tailor your solutions to real subject-oriented information marts. Good chance when we produce a standard report, we create one information mart for this particular standard report. So we end up with a lot of information marts, and they are smaller, which means they're using less entities from the raw vault. That's number one. So you're not going to join all these entities just because they're there. You only join those entities you need for your actual target. That's number one. And the targets are easy to develop, easier to maintain, easier to document and to use because they're smaller, right? That's number one. And then yes, the management of these entities. And we have customers where they have like 15,000 entities. I mean, large customers, right? Where they went for it, right? Where they have 15,000 entities. And they do manage this with automation tools. That's correct. Because and good naming conventions.
When not to use Data Vault, do that zero.
when you don't have any pain. If you have a working solution, why do you think about another solution? Just stick to it. Go ahead. That's a quick one.
If I already have the previous version of how can I migrate to the .0, it's a huge process. It's easier. Yep. What's easier?
Right. If your Data Vault 1.0 project is based on metadata, it's actually quite straightforward, because what you need to do is you need to adjust your templates to Data Vault 2.0. You create new templates for the migration of the data from the old model into the new model, like insert into statements. Essentially, just you can generate them based on your existing metadata. And That's it. And then you have to adjust the delivery, right? But the creation of the data model is straightforward because the metadata is the same or very much the same. So that's easy. If it's not the case, if you build a data vault 1.0 without any metadata, I would consider one of the migration patterns. Consider you have two choices. You either consider the data vault as a source system, I mean the old data vault, right? Or you create a virtualized, you generate a virtualized data vault pattern on top of your legacy data vault, and that's the other migration pattern essentially. There's also a tree.
One is concerning performance. Because you create lots of layers, we create lots of joins. So if you have any reporting tool on top of that, and also concerning this, do you think it's need to build an exploration layer on top of Data Vault to simplify reporting? So let's mix these two ones in one.
So first of all, if you follow the patterns as in a book or in the training, your data ingestion, how you get the data from the source into a raw vault, should be fast by design. That should be extremely fast. The performance problems most people experience is in information delivery. When you try to build your dimensions, your facts based on the entities in data vault. Yes, it's not a lot of entities you need because you don't need to join everything. But the problem is there's a complexity in how you join these entities that requires a left join with a complex join condition. And that kills your performance, the complexity of these joins. And there's a solution for that, and it's called pit and bridge tables. And a lot of people, a lot of projects try to avoid these tables, but they are there for performance reasons, and they're actually simple. So when you use a pit table, it's very much pattern-based, a very technical pattern. It's easy to generate with tools like Warescape. So don't be shy on using them, and they're easy to use. Once you understood them, it's easy to use them. That's it. And bridge tables, they're a bit more, well, not more complicated, but if you know what a pre-aggregated fact table is, you know what a bridge table is, to be honest. So, and that comes from dimension modeling, right? And then the exploration pattern, first of all, I would avoid having too many layers. The data 2.0 architecture has 3 layers. We might have one more for security typically, but I would try to avoid having too many layers. What we do is we can, in a business vault, there are some patterns how we could simplify the access to the entities in the raw vault. By joining all the satellites from the same source on the same parent. That simplifies a bit and essentially makes the underlying satellite splits a bit more transparent. You deal with less entities in the end. And if we modify them, you don't care. So that's what I would recommend, that kind of pattern. And that might be, but that's part of the business world in the end. So that's what I would recommend to deal with it. When you think about a ad hoc data model, let's say you want to implement some industry model for banking or whatever, go for an information mart. Have an information mart that follows a 3NF model or third normal form model or something, or anything else that you want to have. Create an information mart for ad hoc reports, and we do this all the time with most clients.
One of the question is how can I learn more about Data Vault? So we are going to promote together Scalefree and Passio in October. The Data Vault 2.0 bootcamp, and also the certification associated with this. So we will share more information in the next days concerning this training that you are going to promote together. Michael, once again, thank you for your time.